What I want to do is just do a quick review of some of the terminology and ideas around food webs. Now, I know you've covered these before in the past, and so we're just going to cover them quickly here, and we're going to add on to it some thing called ecological pyramids that also help us to show the flow of energy and nutrients through the biotic component of an ecosystem. The purpose of food webs is to show the nutrient and energy flow so that we have an idea of how things are going, and they allow us to see the interactions between organisms as well. Now, before we dive into this, what I'm going to do is I'm going to put up a number of terms, and I encourage you to pause the video so that you can get down the definitions for each of the terms. Okay? So we have ecological niche, which is our role in ecosystem. We have our food chain. We have our trophic level. This is the position they are in food chain. We have our producers, primary consumers, secondary consumers, and tertiary consumers. Now, another thing that I might put in this list that's not here is a keystone species. This is a species whose presence in the ecosystem is of particular importance. And without that species there, we could have our ecosystem or community come down. And a prime example of this is if we look at starfish on some communities. Starfish are very important because they climb over the communities and they remove mussels and barnacles and other things and allow new species to come in. And so if they aren't there, then the ecosystem gets crowded and we can have problems. So I encourage you now to pause and copy down all of the definitions of the terms. Now, we know, as we said before, the sun is the source of all of our energy in the ecosystem. They're used by our producers to then create our carbohydrates, our simple sugars, and they also use minerals and nutrients to grow. And then these are consumed by a variety of organisms, primarily our herbivores or our omnivores. When our producers die out, just like all our organisms, our decomposers will break them down, and then carnivores will consume the herbivores. We're going to go over this a bit more detail. Now, we know our food chain is our sequence of organisms, feeding on each, showing the energy transfer. And we start off with our producers, always at the bottom or at the start of our food chain. They're eaten by our primary consumers, which are also known as herbivores. Then herbivores or primary consumers are eaten by secondary consumers, also known as carnivores, and they can be eaten by our tertiary consumers, which could be considered a carnivore or a top carnivore, but also this is where omnivores would fit in because they eat secondary consumers. Okay? And so, for example, we look at an ecosystem where wild grass would be my producer, and then it's eaten by a snowshoe hare. This is my herbivore. The snowshoe hare is eaten by a hawk. This would be my secondary consumer because it eats herbivores. And then a gray horned owl would be my tertiary consumer because it eats the hawk. Okay? Another example is if we look at the same ecosystem, we could have a pine tree in this ecosystem. And the pine tree, in particular the seeds from the tree, are eaten by a squirrel. And then the squirrel is eaten by the hawk, and the hawk is eaten by the owl. So what this shows us is that in an ecosystem, we can have multiple food chains. And rather than list them as multiple food chains, what we will often do is just show all of the interactions between the organisms in the form of a food web. Okay? And it shows a representation of all the feeding relationships in a community. Okay? So if we start off with our community that we were doing, and you have space on your sheets to write this out, at the very bottom of the section with all of the arrows, you will see that there is a spot for our producers. We always put our producers at the bottom. Okay, and so in this ecosystem, the producers that we're looking at are pine trees, blueberry bushes, aspen trees, and wild grass. These primary producers are then eaten by our herbivores, and so they go one level up, and we try and place all of our herbivores on the same level. Okay? And then our herbivores are eaten by our primary consumers, and so we put them another level up. We're trying, when we place the organisms in the food web, we're trying to maintain, and we can see our trophic level. So here's our first trophic level, the producers. Our second trophic level are herbivores. Then our primary consumers. And then finally our top carnivores. And so we can see that food webs can get rather complicated. Key thing though is we try and keep organisms of the same trophic level on the same line. And the arrows always go from the thing being consumed. So for example, from the aspen tree to this thing consuming it, the snowshoe hare. So this shows me that the snowshoe hare eats the aspen tree. Okay? And then I go from the snowshoe hare to the goose hawk. And it shows that this hawk consumes the hare. It always goes from the thing being consumed to the organism consuming it. Okay? So in this ecosystem, we can see that there are lots of relationships. Now, sometimes this is really complicated or it has more information than we're interested in. And so what we can do is we can use what's called an ecological pyramid to represent our information. And what we do is we look at what's occurring at each trophic level, and there are three types. There's an energy ecological pyramid, a biomass, and a number. Now the size of each layer is proportional to the amount that factor is in that trophic level. Now, when we're looking at our energy pyramid, a couple of things. We know that each trophic level uses some of the energy they consume. So for an energy pyramid, the level above it should always be smaller than the level below it. Okay? Also, when we're doing them, we should also keep in mind that only about 10% of a energy that's on one level is transferred to the level above. So therefore, let's say I had an energy value of 100 joules in my producer's level, only 10%, so I'd only have 10 joules in my herbivore. And then when I go up to my carnivore, I'd only have 1 joule. And when I go to my secondary carnivore, I only have 0.1 joules. So we lose 90% of the energy at each trophic level, doesn't make it up to the second. Because this is the energy that organisms use to carry out their life processes. So if we look at our energy pyramid, we're going to look at the same community. We have our producers. And so we've measured our value and we've determined a scale. And we've made a box for their level proportional to the value. And it goes on the bottom. And then on top of that, we now have our primary consumers. These would be the organisms that consume it. We notice if we look at the size of this, and then we look at the size of this, our primary consumers are much smaller than our producers because only 10% of the energy from this trophic level is transferred to that trophic level. Now when we look at our secondary consumers, again, this trophic level is much smaller than that one in terms of size because only 10% of the energy here is transferred to there. And finally, we have our tertiary. Now, this shows us one interesting fact. Because the vast majority of the energy from one trophic level is not transferred to the next, we can see that most of our food chains or our relationships in the community are only 4 or 5 organisms long. Because I would have to consume a lot of goose hawks to be able to get enough energy to survive, whereas I could consume much more down here. I have much more available food and energy. Now, unlike the energy pyramid where each subsequent layer is smaller than one below, we don't necessarily get that when we look at our other pyramids. Okay? For our numbers pyramid, what we do is we count the number of organisms in each trophic level. And so, for example here, if I had a community that consisted of a very large tree, I might only have 1 tree. But then feasting on that 1 tree, I could have 1,000 insects or 10,000 aphids, which are much smaller in size than a tree. And then on those aphids, I might have a whole bunch of birds feeding on them. And so as a result, the numbers doesn't necessarily. This level could be small, this could be big, and then this one could be big, or it could be small again. So this layer could be much smaller than that one. It all depends on the size of the species that's doing the consuming. When we look at biomass, we generally have the same pattern as the energy pyramid, where the level below is larger than the level above. And so my producers would be larger than my primary consumers, larger than my secondary consumers, and my tertiary consumers would be the smallest.